Right, when we're looking at sequences, if we take the limit as the number of that sequence goes very large or approaches infinity, and that sequence approaches some value L, where L is a real number, then what we say is that this sequence is convergent or converges to that number, so it's convergent. If we do the limit as n gets very big and it doesn't approach anything, then we say instead that the sequence diverges or is divergent. So we want to check, does it approach some actual value? Here's some graphs of ones that would be convergent, meaning they approach some value L. So here you can see these dots represent the different values in that sequence. So we got dot here, here, and so on. And initially it looks like it's kind of increasing and maybe won't approach anything, but then you can see these dots start decreasing and they actually approach some value here, L. So we would say this one is convergent to that value L as we go to infinity. Here's an example of another one. Although this one kind of oscillates, meaning it goes up and down, these oscillations get lower and lower, and so eventually they are again approaching that same value L. So both of these would be convergent. All right, let's look at some properties. All those limit properties that you looked at when we first learned about limits all hold for these sequences. So if you have two convergent sequences and you are finding the sum, that's the same as splitting these up into two different ones. Same with subtraction, we could subtract them. If there's a constant c, that's being multiplied to some sequence, that's the same as c times the limit of that sequence. Multiplying holds the same as adding, subtracting. So if you multiply these two, that's the same as both the limits multiplied together. Division, same thing. It's just that that bottom limit can't equal 0, so we don't have dividing by 0 going on. If you do a power, same thing. So if you got the limit of this sequence to a power, that's the same as just the limit of that sequence to that same power there. So these are all properties that we can use when evaluating. All right, so let's see if we can determine this sequence. This is one we looked at previously in the notes. Determine whether this sequence a sub n over n plus 1 is convergent or divergent. Remember the sequence we get from this, if we plugged in 1, we would get 1 over 1 plus 1, so 1/2. If we plug 2 in, it'd get 2 over 2 plus 1, which is 3. So each of the top and bottom numbers are increasing by 1, but that bottom number is 1 more. So is this sequence approaching something? I think we could probably guess that this one, as we get really large, if the bottom number is just 1 more, think about if we got really, really large here. Like what if our bottom number here is like 1,000,000? Well, then our top one would be 1 less. It would be 999,000. Well, what's that very close to? I would guess that that's pretty close to 1. So I think this limit would be approaching 1. Let's see if we can show that. So to show it, we're going to do a limit here. So what we want to do is take what's the limit as our n gets very large here, n approaches infinity, of our nth term, n over n plus 1. So remember, how did we evaluate these limits again? Well, we want to, anytime you're approaching infinity, we want to multiply by the 1 over the biggest power of the denominator. Here that'd be 1, so we'd want to multiply both numerator and denominator by 1 over n. So what's that make our limit now? Well, we'd get the limit as n approaches infinity. The top would just be 1. On bottom we'd have 1 plus 1 over n. As we go to infinity, remember 1 over n, that approaches 0, so this is now 1 plus 1, or 1 over 1 plus 0, which is just in fact 1. Yeah, so this limit is approaching 1 here, which what we would say is this is a convergent sequence. Here's a graph of it so that you can kind of see it's also approaching 1. So if you graph out these points here, notice all these sequence values keep getting closer and closer here to a value of 1. All right, let's try another one here. So next one. Determine whether this sequence is convergent or divergent. So we want to, if you're there asking this, you want to do what's the limit as n goes to infinity of this a sub n value and see what this comes out to be. Well, if you plug in infinity right now, this would be infinity. On top, that natural log graph, remember, looks like this. That's also going to increase as n increases, so that's also going to infinity. That's one of those indeterminate forms. So what are we going to have to do on this limit to evaluate then if you get an indeterminate form? You guessed it, L'Hopital's rule. So we want to take the derivative of both the top and bottom here and see what we get. So derivative of the top would be 1 over n. Derivative of the bottom would be 1. So now this is just the limit. If we got over 1, we don't need to write that. It was just this. And what is that going to equal as n goes to infinity? That one's going to 0. So this one is a convergent convergent sequence. All the numbers in this one are going to keep getting closer and closer and closer to a value of 0. Let's graph this one out to see that it does approach 0. So you can graph sequences. What you want to do is hit your mode button and then change it from function mode here over to sequence mode. So this last one right here, sequence. Then we're going to go to our y equals and type in this function. I've already got it typed in here, natural log of n over n. So then let's graph it. Now this one, to see it better here, let's go to our window and let's be a little more specific. We know that we're only dealing with a positive value. So I'm going to start this at 0 and let's go out to maybe 15 here. And then our y values, it looks like are all going to be positive when we put these in here. So let's start this at 0, and then I don't think it's going to get much higher than maybe 3 or 4. Let's just put 3 in there. All right, so if we hit graph, we should see those points in there. So there's our points. You can see on this graph that the points initially start going up here, but then they're starting to go back down and approach 0 as we keep getting further out. So yes, that is convergent to 0. All right, next one. This one's asking, is the sequence again convergent or divergent? So for this one, as we go to infinity, what's going on here? Well, let's look at if we just start putting some points in here. If n equals 1, this would be -1 to the 1 power, so the value would be -1. If we did -1 to the next number squared, that'd be -1 squared is -1 times -1 is +1. If we did -1 to the 3rd power, if we multiply 3 -1s together, we get -1. And you can start seeing the pattern here. It looks like we're just going to alternate there between 1 and -1. So if you graph this one out on your calculator, it would end up looking like this. Well, are those dots approaching anything? No, they're just jumping back and alternating between the two values. So in this case, we would say the limit as n approaches infinity on this one does not exist. And so this would be an example of one that is a limit that is divergent. It doesn't approach anything, and the reason would be it just oscillates. Oscillates is a term for oscillates. Is a term for just going back and forth between two values. So it just oscillates between 1 and -1. So it's never going to approach anything. So not all sequences are convergent. This is an example of one that is not.